Good morning, students. Beta, from last few days we are doing the interference, and I covered all the topics of interference. Only one thing is left, that is whether the law of conservation of energy obeys in interference phenomena or not. So let's start our today's topic. Bache, all of you did this law of conservation of energy in your 11th class, and you know, as per this law, energy can neither be created nor destroyed. It simply changes from one form to another form. And I think all of you very much familiar with this interference phenomena now. And you know, the interference phenomena is the redistribution of energy when light coming out from two coherent sources superimpose. When the light wave superimpose, we get the pattern on the screen. Beta, the pattern which you get on the screen, on that pattern you get the alternate bright and the dark bands on the screen. We already did this. But you get the dark spots or the destructive interference only when the two waves which are superimposing are out of phase, and when you get the bright spots when the waves which are superimposing are in phase. So the destructive and the constructive interference all depends upon the superimposing of the waves which are coming out from the two coherent sources. It's not clear? Is it clear? Yes, it's clear now. Okay, but so in interference, destructive interference takes place when two waves are out of phase. In interference, when two waves are out of phase, we get destructive interference on the screen at some spot. It means by destructive interference we mean that the intensity at that point, or I can say the amplitude at that point on the screen, or energy of the wave is zero. When we say zero, it means the energy or intensity at that point is completely destroyed. Intensity at that point is on the screen is completely destroyed. But bacha, you know, there is no word like destroyed, because as per the law of conservation of energy, energy can never destroyed. So when we say energy is destroyed, here by destroy we means that energy which disappears at the point of destructive interference, it appears at the point of constructive interference. In this intensity or this energy does not go anywhere. It simply disappears at one point, at the same time it appears at the another point. It is changing from one point to another. So by destroy we means but energy never destroy. So what happens here? It's simply energy which disappears at point of energy disappearing at point of destructive interference, it appears at point of constructive interference. Means this energy, this intensity is simply, it means it is simply redistributing. So law of conservation of energy holds in interference phenomena, that energy does not goes anywhere. It simply which disappears at one point, it appears at the another point. Is it clear, beta? Okay, let me explain you this by coding an example. Suppose beta, there are four friends, and We are distributing chocolates among them by giving one chocolate to each friend. I'm just simply, firstly, what I did, I simply give one chocolate to each friend. Then after that, I take the chocolate from the first friend and give it to the second one. So the first one will have no chocolate, zero chocolate, and the second one will have two chocolates. And the same thing I did with the third friend. I took chocolate from this third one and give it to the fourth one. So the third friend will have no chocolate and the fourth one will have the two chocolates. Initially they have the four chocolates, and when I redistributed the chocolates among them, they again have the four chocolates. So chocolates does not go anywhere, they are with them only. In the same way, energy does not go anywhere, it is here only. Is it clear, beta? Beta, we can also prove this law of conservation of energy, whether holds in interference phenomena or not, mathematically also. Okay, let me show you the mathematical explanation. But in mathematically will only show that energy before interference, intensity, or I can say energy before interference is equal to intensity after interference. Will show only this. If the before and the after interference intensity or energy remains same, it means law of conservation of energy holds in interference phenomena. And beta, you know that interference phenomena was studied by Young's, and we also did its Young's double slit experiment. Now see here, bache, S1 and S2 are the two slits. Here we are taking the condition that initially no interference is taking place. The width of these slits S1 and S2 is adjusted in such a way the waves which are coming out from these slits, they do not superimpose. We simply get, corresponding to these two slits, we simply get the two spots on the screen. Means initially our apparatus, which apparatus? Young's double slit is adjusted in such a way corresponding to slits or to coherent sources S1 and S2, we get only two spots on screen. Means we get only this light on the screen. These waves are coming out from the sources S1 and S2 do not superimpose. Means before initially we assume no interference is taking place. How can we get no interference is taking place? We simply adjust the width of the slit. It's such a way that no interference is taking place. We simply get the spots, these two spots on the screen. And here when we did the conditions for the constructive and the destructive interference, that time we consider the amplitude of the wave emitting from S1 is A1 and from S2 slit is A2. But here we'll suppose that both the amplitudes are same. Here we suppose both the amplitudes are same. Now see beta, as we know the intensity, that intensity is proportional to the square of the amplitude. We'll use this relation to find the whole our mathematical part. See beta, as we know that intensity is proportional to the square of the amplitude. So the intensity of the wave which we get from this source S1, we are assuming it by I1. Intensity of the light emitting from source S1 is I1. It is proportional to the amplitude of the wave. As we are we just suppose that the amplitude of the both the waves is same, so it is proportional to the A. Or we can say the intensity of the first spot which we get on the screen or the light, when we remove the proportionality sign, we get the constant of proportionality A. In the same way, intensity of the second wave emitting from this source S2 is, it is also proportional to the, it is square of the amplitude. I forgot to write the square over here. It's proportional to the square of the amplitude, and the amplitude of the wave emitting from S2 is also A. We just assume here. When we remove the proportionality sign, we get the constant of proportionality. So the total intensity, now the total intensity when there is no interference, I is equal to I1 plus I2. When I add this both I1 and I2 here, what we get, it is K of A square plus K of A square. So K is common, A square plus A square is, both are same, so it is 2K A square. So this is the intensity when there is no interference. Now we are considering the case, the width of the slit S1 and S2 is adjusted in such a way that we get the pattern on the screen. We get the alternate bright and the dark bands on the screen. Now interference is taking place by adjusting the width of the slit. Now see bacha, as we know that intensity is proportional to the square of the amplitude, and we already find the amplitude of constructive interference in our previous lecture. We know the amplitude in case of, which we also denoted by A max, amplitude of the constructive interference is A1 plus A2. This we get in our last to last lecture when we find the condition for constructive and the destructive interference, and we also find the amplitude of destructive interference, and that time it comes out to be A1 minus A2. Okay bacha, we find these two amplitudes at that time. Now beta, as we are assuming here that both the amplitudes A1 and A2 are equal, so the amplitude of constructive interferences, it is A plus A, or it comes out to be 2A. This is my for constructive, and we know intensity is proportional to the square of the amplitude. So the intensity of the constructive, or I am denoting constructive by maximum, is equal to K times of amplitude of this, K times of square of the amplitude of this maximum amplitude. When I substitute the value of maximum amplitude, it comes out to be 4K A square. So it is the maximum intensity, or the intensity corresponding to the bright band. Similarly, we know A minimum is A1 minus A2. We are substituting, suppose here both the amplitudes are equal, so A minus A is equal to 0. When their intensity amplitude is 0, then obviously their intensity also comes out to be 0 when we substitute here. Now beta, we will calculate the average intensity. Now the average intensity, I is equal to, how we calculate average? By adding both the intensity, maximum and the minimum intensity. We are adding the only two, so we are dividing it by 2. Beta, you can consider, we find on the find the number of bands on the screen. So you can consider this case for n maxima and n minima also. I am taking only 2, so I am dividing it by 2. So the value of I max was, it was 4K A square. It's 4K A square plus 0 divided by 2, or this is 4K divided by 2, this 2 and 4 get cancelled, we get the 2K A square. So This is the intensity we get. This intensity we get after interference. So from this equation and what we get before, we can say that both the intensities before interference and the intensity after interference are same. So law of conservation of energy holds in interference phenomena. But I explain you this whether this law holds in interference or not in both the ways, in mathematically and by giving explanation also. And I think now it's very much clear to all of you that yes, this law holds in interference phenomena. Thanks, beta.